Hello, welcome back to another creative process video. So this time I'd like to have a look at FM synthesis, and this is something that I'm not an expert in, so in a way you're going to get to see me get into grips with it. My first experience of using FM was back in the 80s with the DX7. I was at a college called London College of Furniture, and that was from about 84 to 87, and at that time the DX7 came out and the world was introduced to FM synthesis, and it was quite a revolution for us. We'd never heard sounds anything like it, and after a while one of my friends at college managed to get hold of a DX7. He bought one. He must have been incredibly rich. I don't know how he managed to do it, but anyway, he got one. And even more incredibly, he lent the thing to me. So I ended up having to lug this thing back from East London to the Medway towns, and it weighed an absolute ton. And I wrote a couple of pieces, really sort of sketches, shall we say, and I've still got them, and I've put them up on SoundCloud so you can have a listen. Quite interesting to hear something that's so incredibly old, and I still kind of like them actually. I think they're okay. And also you get to hear clips at the beginning and the end of this video. What else can I say about it? So I wrote the pieces, and then of course I had to lug the keyboard all the way back to London. He never lent it to me ever again, even though I think I don't remember damaging that one. I may have damaged another synth. I don't remember. Anyway, possibly I may have damaged something. I'm not sure. But anyway, he didn't lend it to me again, which is probably just as well, because my arms couldn't handle carrying it a second time. So then fast forward a significant number of years to 2017, and I've started at that point to build a hardware studio again, and I now have this wonderful TX7 module, much smaller than DX7, but it sounds exactly the same. So when I got the TX7, it wasn't fully working, but I was kind of lucky because there's some good diagnostic software on the box, and if you just run through that, it actually tells you what's wrong. And it told me in absolute plain English that one of the memory chips had failed, and I think it cost me something like £10 to get a new one on eBay. Just replaced it, as you can see in these pictures, and it works fine now, so that's really good. And I'm using the DX Manager software to program it. I've only done a couple of basic things with it, and I've worked out a few things, but now I'm just going to have a more in-depth look and maybe set myself some targets. Let's try to create certain sounds and work out also what are the strengths. Let's have a look at some of the differences in the algorithms and how they work. Just to put it in context, I know how FM works, and I even got to the point of studying some of the maths of how it works when I was at college. But it's the predictability of the sounds that you're going to get depending on what you're doing that's going to be the real trick with this, and that's something I've got less experience of. So let's have some fun mucking around with that, try and get some sounds sorted out, and see what we come up with. Okay, so I'm on my music workstation. I'm going to start up DX Manager, and this is the editing software for the TX7. So I'm just going to run through how you would set this up for the first time. What you need to do is establish communication. In the case of the TX7, then that's the MIDI interfaces, but you need to connect both the in and the out. So you do that just by having a look at this setting here. And I've got this 8-way MIDI Sport MIDI interface, quite an old thing, but it works. Even with Windows 10 it works, which is kind of incredible. And the in and out is connected on port 2, so there you go. There's really nothing else to show there. and I'm going to click OK. Now when I click OK, the patch viewer has come up and it's downloaded all of the patches which are in the TX7, and I can see them. Now the problem I've got at this stage is that if the MIDI is connected in and out to the TX7, then how can you play a keyboard so that you can get some sound rather like I'm doing now? And the answer to that is that it has built-in MIDI function, MIDI merge. It scans all of the MIDI interfaces you've got, including in this case a virtual internal one which my DAW is connected to. And I've got a keyboard connected to my DAW. The DAW is then connected to this, and that means I can play some sequences back later on. I believe I do not need this anymore, so I'm going to close that. We know the communication is working, and I'm going to get bank. What it's done at this stage is it's gone to get the voices, but it's displayed them in this format. I can then go save as, just call it test 2. There we go, save. Now if I then open, the software comes with a couple of files built in, and this is actually quite useful. So I'm going to open this one up, and again drag it across to the screen. But here you can see there are all kinds of strange things. If you're a big fan of Rush and Steely Dan, you're going to love this software. Otherwise, maybe not so much. I'm being unfair, actually. But obviously you've got different types of sounds here, so it's going to give you loads of opportunities to start with a particular sound and maybe do something with it. So let's I'm just going to pick something random. Reed trombone, that's not quite right. Let's go for flutes, pipes. I'll tell you what I'll do. Save me destroying your ears. I'm going to press play here in the DAW. Yeah, that's the sort of DX sound that you recognize with that sort of chuffy noise at the beginning. Some squeaky noises. It's quite nice. You could spend hours going through these, and I probably will do later on. Okay, I'm going to stop that for now. Right, so that's the basics with patches, how to save them. So at this point then, you're probably wondering, well, how can I actually start editing things? Which is a perfectly reasonable question. So your starting point a lot of the time is perhaps going to be a sound you've already got. So if I double click on that now, all of a sudden we get the editing window. So yeah, so if you wanted to sort of deconstruct how a particular patch works, then this is a great way to do it. For now, let's assume that we want to start from scratch. Now, if I go here, new, there we go. So now it's doing a new DXM file. Okay, so I've opened the patch window. What I want to do first of all was actually just change the name. Let's call it pad 1 just in case we go any further. Right, so now I'm going to go to the editing window. Okay, and as we can hear, it is initialized already. So what I wanted to do for this first exercise is try and do, as the name would suggest, a pad. I had something kind of stringish in mind. I don't know how easy it's going to be to find that sort of sound, but I'm going to try one particular approach and just see where it gets us. So let's first of all check on an algorithm. So I was thinking of going for something like this, either this one, algorithm 6 or 5. So what we do is let's have a quick talk about the way FM works. The basic sound production is done via the operators, and the operators are sine wave oscillators. Simple as that. Each operator has an envelope, which you can see here. They're a bit like an ADSR envelope, but they're a bit more advanced. You have a few more options. And the envelope shapers shape level. But as they're all sine waves, then you need to have a way in which some kind of timbre is generated. So now, as you can see here, we have all 6 of these oscillators, which are referred to as operators. And you'll notice that there are 3 at the bottom and 3 at the top. Now what's actually happening here is, and if I disable those 2 for now, when I play a note, I'm only hearing this operator, this oscillator. It's a sine wave, and that's all I can hear. Now, in order to make that have a different sound, what I need to do is turn up the level of this second operator, and what that will do is then modulate the sound of this, frequency modulate it, and then change the sound. So I'll do that now. And we can do that down here where it says output. So you can hear there is a tonal difference now. And as I go down to the bottom again, we're back to sine wave. So I can then just create basic waveforms just by changing that. Now if I want something that changes, then I need to look at the envelope shaper for operator 2. So let's slow this down a bit. Let's maybe take the sustain down to a certain level. Let's see what that sounds like. And then we've got something which doesn't sound dissimilar to a filter sweep. There we go. So we could let's try that with some chords. Okay, so we've already got something very simple just with 2 operators. One which is the carrier, you hear the carrier, and the second one is the modulator, and that's the one that is modulating the carrier, so you get something more than a sine wave. The thing that's worth noting at this point then is the sound that you're going to get from the modulator will depend on what frequency it's set to. So at the moment, both operator 1 and 2 are set to the same frequency. Now if I change the frequency, it will change the sound as well. So if I put it up to 2, or 3. So these ratios actually relate to harmonics in the harmonic series. So that's the 4th harmonic. And the higher it goes then, the more distant the harmonics are. And also the more you can expect that particular harmonic to influence the sound. So they're becoming more and more distantly related as they go up. And you get in something which is sounding more, shall we say, dissonant. So you can also have a fixed frequency. So it means that your carrier will always be modulated by, in this case, 100 Hertz. And that would mean that the relationship between the notes is different for every single note. Whereas if you go back to ratios, the ratio is always 1 to 3. If you go to fixed, the ratio is always 1, which would mean whatever note you're playing, to 1000 Hertz. It's always 1000 Hertz. Okay, so I've just set that so that it's always the same timbre. The envelope is not going to change anything in terms of the sound. It's always the same. Okay, a few more tweaks. So I want it fast, going up to a certain level and then slowing down. That's actually quite a good way to get something to happen instantly, but at the same time still feel quite soft. Okay, I think that'll do for now. Now, some really good features here that can really save a lot of time. But at the moment, of course, we're only using these 2 operators, and we have another 4 to deal with. Now, I've fiddled around with those envelopes. I don't really want to have to do it all again. So I literally just click on the envelope that I want to copy and then drag it over to the envelope that I want to change. So I want to put 2 on 4 and 2 on 6. Then if we have a look at the operator levels, then all of these need to go up to 99 there, and then 91 here, 91 here. The only difference there is that it's louder because there's now 3 of them. But I do want to change things a little, so what I want to do is change the detune a little bit. So I'm going to take that down 2 on operator 3, and I'm going to take that up to, there we go. Right, so we've done the detune. It's at this point we could try out some different ratios. Now they're much brighter when you go up. So what you can do is take the amounts down. And they all also get brighter as they go up the scale. A lot brighter. So what we can do is offset these. So if I put it back a bit. But I kind of like it. It's got a nice sort of fizziness to it. So okay, I think that'll be my pad. So back again for patch number 2. So I think the first thing to do is let's have a look at the algorithm. Now what I want is 2 groups of 3. There we go, algorithm 3. So in this one, we have the situation where a modulator is going to modulate a modulator, which is then going to modulate a carrier, and that happens twice. I've got an idea I want to try out, so I want to go for something that's kind of percussive, but be good for arpeggios, and sounds a little bit sort of bell-like. So maybe like a xylophone or vibraphone type thing going on. So let's see what we can do with that. So first of all, I want the soft sound first, and I think I'm going to go for no sustain at all on this one. So it's going to disappear. Rate 3 is at 52. So in many ways, it's a bit like a piano then at this stage. Okay, so now we want to introduce some character. Okay, that's fine. So basically I want it to be the same sound all the way through. I'm going to go for the 7th harmonic. I'm going to try some of the other ratios. So I would expect even numbers to sound plainer. So 4 certainly doesn't sound quite as metallic. I mean 3 doesn't either, but it's closer to 1. Almost piano-like in sound, that one. It's interesting how the character changes so much. So why not add another one then? So let's put the 3rd one in. Okay, I'm going to put the ratio for the 3rd one up to 7. So you've got 7 driving 5, then driving the 1. And the envelope shaper I'm going to just copy across, and the level let's get into harpsichord territory there. Let's give it the same amount, 67. You can definitely hear the difference if you turn that 3rd operator off. Okay, that's the first 3. So what did I have in mind for the second 3? Let's turn this off. So I'm just going to hear, just got operator 4. So what I want is something that's going to act as a little clunk at the beginning. Put this up to 99 and then turn that on. And I think it would be interesting to perhaps take that to fixed. that's really interesting. I'll do the same here. Turn 6 on. So the whole thing's too loud, I think. So we could scale up. Let's try scaling. Yeah, so that's pretty much it. So basically, just add in a bit of a thump. I've put some random frequencies in these operators, which are then driving operator 4 and a very shorter envelope. So you've got a slightly noisy, chaotic sound. Then you combine it with the bell-like sound, and you've got something that sounds like it's having a thump, and then there's a decay. So that's sort of perfect, really. Yeah, I like that. I really do like that. That's good. So that's it for the introduction. Hopefully you got something useful out of that. I certainly did. Playing with the TX7 and trying different sounds has really helped me understand a lot better how I can get something out of the device. And I'm really looking forward to going back and doing some more sounds, perhaps some more experimental things, and try and get some truly unique sounds out of it, which I'm sure is more than possible. So I'll definitely be revisiting that, and if I discover anything or enough things to make it worthwhile, then I'll have do another video, do a part 2. Certainly let me know if you think that would be of interest. One of the reasons I wanted to do something about FM is that it comes from that period of the early to mid 80s where there was a great deal of innovation, and people were trying all different types of ways to create new sounds. And I've got a number of synths from that period, and they all have their own characteristics. All of that early digital stuff is very interesting. So that's something that perhaps I'll have a look at that in other videos. Quick apology that it was so long. It's amazing how much time you have to spend doing patches, but you probably know that already. So that's it, and thanks very much for watching. I mean, again, if you made it this far, then well done. It's another long one. Really hope it's been worthwhile, and hopefully catch you on the next one. And please do all that YouTube stuff for me, the likes, the subscribes, all of that. It's all helpful, and it makes it worthwhile, me doing this stuff. So until next time, enjoy your programming.